Welcome to our webinar on the Internet of Things. Ed and I want to thank you for attending. We also want to especially thank Paula and Helene for setting this up and hosting us. The Internet of Things was first coined in an article in the RFID journal in 2009 by Kevin Ashton. And in the article, he discussed the fact that the Internet at that point was mostly receiving data and input from people, but that in the future, more and more inanimate objects would be attached or joining the Internet of Things. And that's at the point, he said, the Internet of Things has the potential to change the world, just as the Internet did, maybe even more so. And the reason why this was published in the RFID journal, as you'll see, is that RFID will play a major role in this process as one of the enablers of being able to connect machines and other inanimate objects to the Internet. So let's ask a question. Our first question to get us started is, what impact is the Internet of Things having on your business? And here's some possible responses. So it looks like we have a pretty even distribution across all of the points. Some seeing no impact at all, and others finding it very disruptive. And what will happen as we go forward into the future is more and more industries will be impacted, and it seems like most of you have already started to feel something with respect to the Internet of Things and its impact on your business.
Was there?
Well, let's take a look at the Internet of Things over time, where we've been and where it looks like we're going to go. As I mentioned before, RFID tags were one of the early enablers, and they facilitated routing and inventory and loss prevention. And as the top 10 suppliers of Walmart know, Walmart has had a major push to involve their largest suppliers and eventually all their suppliers so that they will be able to have an RFID chip in all packages, in all products, which will dramatically change their operations, both on the supply side and on the end consumer side. So the Internet of Things has started initially with supply chain helpers, and some companies now, as they're receiving shipments from other countries, as soon as the ship enters the territorial waters for the country, like the United States, now pick that up on their inventory and the payment is made electronically. Now, then we moved more recently to surveillance, security, healthcare applications. More and more medical devices are being connected to the Internet so that the doctors and hospitals can monitor them. An example would be a pacemaker for a heart. We're starting to connect more and more everyday objects like automobiles and mobile phones to the Internet through global positioning. In the near future, we will have more and more inanimate objects connected, and some communicating with one another, device to device. So an example would be that, like in a factory where we have embedded diagnostics in machines, one machine starts to overheat or need some maintenance, it can transfer the information to other machines to pick up the manufacturing process. The implication of this is that more and more inanimate objects, and Gartner predicts some 26 billion, and people say that's an underestimate, will be connected to the Internet of Things by 2020. And California has already passed a law for self-piloting vehicles. In 2020, self-piloting vehicles will be allowed on the roads in California. And there are already, as you probably know, Google is running a number of self-piloting vehicles already in California under a special test. The implication of that, if you look at the top, is that the amount of information managed by a company and their data centers will grow at least by 50 times this decade as all of this inanimate data, 24/7 data streams into our databases. So let's take a look at the enablers of that. RFID started it, but now they're developing near-field communication devices that can be used in many different situations. There's actually inserts for people, animals, and barcodes will enable this, but the generic barcode is already out of numbers and codes, so we're moving now to the dimensional barcodes like QR and Aztec and data matrix, and more direct information will come from microprocessors and sensors embedded in all kinds of products. Take a couple examples. Pratt Whitney manufactures jet engines, and in most of their engines now they're starting to place sensors. On one transatlantic flight, a single engine generates 500 gigabytes per engine of data. Pratt & Whitney gave IBM 18 months. So if you take an airline like Delta with about 1,000 planes, 500 gigabytes of data per trip over the Atlantic Ocean, I don't know how many exabytes of data that was, but IBM used that data to predict 97% of engine maintenance events and 100% of incidents that might require turning off an engine. So it enabled Pratt & Whitney to streamline their maintenance to do it at just the right time rather than on a time-based maintenance schedule. SKF makes intelligent ball bearings that are able to sense temperature, oil viscosity, and are used to manage manufacturing ecosystems, machine to machine, and the entire factory plant now becomes a large system communicating with itself. So the problem coming out of all of this is that big data really isn't big yet, but big data will become bigger and bigger, more and more data. And when we look at the definition of big data, there's three characteristics, or there has been noted that it's huge volume, fast velocity, rapidly arriving, and also the variety when we lump social media and other types of data in there. But in our thinking, the missing V is value. So there's lots of applications for the Internet of Things and lots of applications to generate by mining big data, but where is the value? So we can take examples of consumer products, and most of them seem trivial to me, except for the automobile, mobile phone perhaps. But when we look at B2B company, there is in our minds, and we have some examples of where there is real value to be mined from the Internet of Things and the data that it will be generating. So here's the road that we're headed down regarding predictive analytics. And at one point, we were just looking at data, say ad hoc reports and online analytical processing. Some companies had cubes where they could slice and dice their database. I worked with Southern Company, and they had a cube. They could slice it by customer, by product, by geographical area. But those were all query-based, and those told us what happened, but not why it happened, or being able to predict what will happen, or being able to optimize. You know, if we act now, seeing what's happening, if we act now, how can we improve that? How can we improve our maintenance? How can we improve our factory operations? Some people argue that online analytical processing is almost obsolete. I know at UPS, for instance, the #1 corporate job title here in Atlanta is data marketing analyst, and they have 300 data marketing analysts that do deep dives every day into their database. They have a system called Total Track, and it costs about $1 billion annually to maintain that database and do queries. But we want to move more to why did things happen, and then predictive analytics are modeling what will happen, and then also what is the best could happen if we intervene at this time. So that's the path that we're headed down toward, or of analytics maturity. And here's a quick description, the differences between analytics and predictive analytics. So with analytics, we're trying to understand the past. With predictive analytics, we're trying to gain insights, make decisions, and take action. And it's future-oriented as opposed to historical. We're working with leading indicators. It's structured and sometimes unstructured. And the more and more data that we get from machines will be unstructured, but huge. And more users are at the C-level and senior management because it deals with profitability and productivity and the future strategy of the company.
Wes, I think it's also important to point out that increasingly predictive analytics is being used in what I'd call context-sensitive situations. So it's actually leveraging the data about a machine's environment to make predictions for that individual machine and that location and that usage application, and when it will need service or when it will need an intervention. So it really is a big departure from historical reactive analytics, which is looking more at averages and prescribed types of activities, proactive activities, but not predictive associated with that device and that environment. So that contextual approach is one of the things that's really interesting, I think, in the predictive analytics world.
Great. Yeah, good point, Ed. We've actually set up at Georgia State an Institute for Insight. And we have invited all the companies in Atlanta, if they have data and they want to see what insights can be generated from it, bring it over and we'll assign faculty and student groups to do that. Delta's been one of our first respondents, so we're mining a lot of data for Delta to do just what you described. Let's take another example, and that's Walmart. When you look at Walmart, they have about 8,500 stores in 15 countries. Each supercenter has about 140,000 SKUs and takes inventory manually 3 to 4 times a day, sends it by satellite, and they own their own fleet of satellites to Walmart headquarters, and that's forwarded to the distribution center. And 85% of that merchandise is automatically replenished in the store through the distribution center, and that information is sent to all of their suppliers, the 85% that's on automatic replenishment. So that data flows all the way back through the supply chain, and of course there's the possibility for their suppliers to further that information back to their suppliers, and all the way back to the point of parts and raw materials and machinery and that. And RFID and mobile technologies will be a major important part for Walmart in the future. What they'd like to do is, once they have RFID chips in all products, is to have a device that you can take your cart through, and that data goes all the way back to the supply chain. So what we're seeing is the convergence of 3 major future impacts, and that is the Internet of Things, which is generating big data and making it 50 times or more greater than we're currently dealing with. And that is then going to drive or create the ability for more and more predictive analytics. So let's do another polling question. How are you using predictive analytics? Some of you said it's the Internet of Things is disruptive, or where are you at with predictive analytics? Right. It looks like the greatest number is actively exploring how they can use it, but we have some of our attendees already at predictive analytics application, which we are using in their business, a little over 10%. We The Center for Business and Industrial Marketing, in conjunction with ISBM, is in the process of conducting the Trends Poll, which looks at future challenges and capabilities that companies have to build to address those. The number 2 issue is predictive analytics. The number one issue that we're finding so far is better customer relationships. But the second issue that most companies see as a challenge over the next 3 to 5 years is managing predictive analytics and using them to find value. Ed, why don't you take it?
Great. Well, and I think that's a great entry into speaking a little bit about the different types of predictive analytics. We really kind of classify predictive analytics into 2 categories, what we call customer engagement predictive analytics and then operational predictive analytics. In our experience, most of the applications we see today really do center around this customer engagement, trying to understand and predict what the customers are going to be able to do, what is driving their behavior, so that you can have more efficient operations, you can make better decisions from a promotion, really through the entire marketing mix. And that's really where a lot of predictive analytics started, but we're also seeing the operations optimization through predictive analytics. And here is where I think it really becomes pretty interesting, because a lot of businesses are seeing the ability to have an almost immediate impact on their business model and their cost by implementing both the combination, and this refers back to the earlier slide, the combination of near-field communications or digitized devices, basically being able to actually see what's going on with equipment in a real-time basis and being able to leverage that back into their operations, and through that take either predictive actions that could involve everything from service to even product design or operational activities. So a very significant opportunity. And I think really the key thing as we think about this is to really frame our thought process around moving from a reactive model to a predictive model. I like to use service as a classic example of this. If you have a installed fleet of devices, it could be refrigerators, it could be printers, it could be autos, it could be almost anything that you're actually managing for the customer. And what happens in a typical model is you understand what your failure rates are, you know what your kind of time-based maintenance requirements are. So you will staff in a way that lets you, and I'm not sure why we move forward there, that will let you predict when that's going to, when you're going to have failures. And with predictive analytics, what you do is you actually understand when individual devices are going to fail, optimize your service routing, and actually, instead of staffing to your maximum failure rate, you now staff to what your actual need is. And so it really changes the decision making. And this is kind of the cycle or the process that we see with predictive analytics, where you actually go through a process of first collecting, integrating data. You generate models, predictive models, that give you some type of analytical insight. And I think it's very important that we believe you should always be able to tie this to a management decision, to a management action. So be able to actually drive some activity based on this. There's typically some type of display, alert, ERP feed, some type of action that's taken based on that, some way of visualizing the information. And then the cycle continues. Your predictions get better. You optimize the model. You make better insights. You have better insights. You make better decisions. And this is really how it works. I think one of the key things is And again, this refers back to earlier to the big data discussion. It's all kinds of data that you're going to be using. It can be asset management data, it can be warranty data, it can be structured data, it can be unstructured data, it can be operator logs. It's really just a large pool of data that you can potentially be working from. So as we look at this model, this is one example of a predictive analytics architecture. Now, this is actually a architecture from IBM called PMQ, Predictive Maintenance and Quality. It tries to show at a conceptual level the major components. And again, one of the things I think it's very important to understand from our experience in building these models, capturing the data, taking the structured and unstructured data, the big data, if you will, and taking it through some kind of integration bus so that you can actually get it into an analytical set. That is one of your biggest challenges. I think some of the folks mentioned that they had already started on predictive analytics applications, and I think they'd probably agree that 9 times out of 10, a huge portion of the work comes up front initially with the data itself before you even get into the modeling. Once you do that, you build the predictive analytics models, you have a decision management function, a business intelligence function to be able to tie that into your business decisions, and then of course some way of activating the data either through dashboards, drill downs, ERP feeds. So this is just one architecture. There are multiple tools and methods out there for developing this, but I think it's really important to understand that as you start getting into this, it takes some real knowledge and insight to be able to do this. So let me actually take you through one example of an actual application that we've developed, where in this case, there are about, out in the market today, about 100 million printers, MFPs, and copiers that are connected to networks. About 30 million of those devices worldwide are actively managed. So someone is responsible for managing those devices. And today what happens is they essentially, when they go low on toner, they generate an alert. It triggers an automated process in many cases, and a toner cartridge is shipped. The customer gets the toner cartridge, new toner cartridge, walks to the printer. It says, oh, I need to replace a toner. The toner's low, so they replace it. And in reality, because of variances in how people actually use the devices, they end up throwing away up to 25% of the toner. It's a significant amount. So kind of the analogy I use is like if you drove up to the gas station with a quarter tank, and the gas station only sold in full tank increments. So you had to buy 3/4 of a full tank of gas, you fill up 3/4 of a tank, and you pour a quarter out on the ground. It's a pretty wasteful kind of method, right? What we actually have done is built a model that looks at each individual cartridge, not each model or each type of cartridge, but each individual cartridge, how it's being used. It takes the data from that, uses machine learning to actually predict when it will actually be empty, not the estimated empty or the empty based off of a sensor that is typically at a much higher level than actual empty mode. It'll predict that and actually reduce that wastage from 25% to 15% or even less, as low as 5%. So in a typical environment with an original equipment manufacturer that maybe has 1 million devices under management, that equates to about $25 million in annual cost savings. And the operating cost on this is only about $3 million a year, so about an 800% ROI on the cost to operate this. So a very impactful kind of application. This is just one application. There are many applications in the industrial environment. We're seeing it used in automotive, as Wes mentioned, in the aeronautics industry with jet engines. We're seeing it used on railroads. to predict cracks in the wheels and when that's going to cause a failure to avoid derailments. So a lot of very interesting developments. This just provides an example of how the system works. And I think one of the interesting things that we're seeing is now, in this case, it's actually predictive analytics as a service, where the data is coming into a third-party vendor, a fleet management software company called Pratt Whitney. They feed us the data on the devices. We feed it through our model and feed back to them a ship date, which they send to the vendor, and the vendor then automatically ships that cartridge. So it's a very automated process. It's a process that we're seeing in business-to-business environments. These types of models often start engaging your partners, and you see kind of a network effect of implementing these, and you start developing an ecosystem around delivering this optimized model. And real importantly, as you look at this, I think it's important to understand the foundations for how you build these solutions. And again, there are many different solutions. We've developed models, other companies develop models, but I think in all cases, every solution I've seen has kind of four common elements. There is a technology element. It involves not just the statistics in analytical software, but the data integration tools, the platform that it runs on. There's a level of industry expertise that's required. You really have to understand the business model, what the issues are, where the opportunities are for optimization. Otherwise, it can quickly degrade into just a data mining exercise that may or may not be productive. You have to have experienced analytics team. I've seen teams of 9 or 10 people on an individual project. I've seen teams of 3 people on a project, but you always have to have a kind of data architect capability, a data scientist capability, a business analyst, a solution architect at a minimum. And that really is you can't replace that team. It really takes a lot of human know-how to build these models. And then finally, you have to have a process. You have to have a process for assessing the data, for assessing what the use case or business model is, for analyzing how suitable the data is and identifying where you have gaps. And you really have to have all 4 of these things. Really critical building blocks that either yourself or your partner or your vendor has to have to be able to bring these solutions to the table. So we see this as, again, a very exciting and very interesting growth area. And for some reason, I'm having there we go. A very exciting growth area. I think both Wes and I agree from both an academic and a practitioner perspective. This is really something we're going to see, I think, change and shape some business models out there and create some new opportunities in everything from servitization to completely new business models that are really optimized to leverage the connectivity, the Internet of Things, the predictive analytics, and the big data to create some competitive advantage. So I believe we have a few minutes for some questions.
Yes, we do. This is Helene, and we do have a few questions that have come in. The first, in describing the various types of markets, can you do a comparison between industrial and consumer relative to how this impacts each of those markets?
Great question. Wes, I'll take a first pass at it, then maybe hand it over to you, I think.
Okay.
But I think in general, a lot of the same potential opportunities apply, both an operational improvement and a customer engagement improvement. I would probably say, from what I've seen, that on the consumer market side, it really tends to be focused a little more heavily around customer engagement. Whereas on the industrial side, I think we're seeing more work on the operational side of predictive analytics. Would you agree with that, Wes, or have a different?
Yeah, I think I would. Yeah, when I look at a lot of the consumer applications, to me, being a B2B guy, they seem trivial. You know, like having a sensor in your dental floss so it can signal your dental hygienist whether you're using it properly, and then also Amazon.com when you're about to run out. But when I look at the B2B side, I'm looking at operational applications, you know, agriculture, sensing the dampness of the soil and determining when's the best time to irrigate, airlines using it for their engines, in the medical area. Yeah, of course, that would maybe be on the consumer side, the monitoring of medical devices, pacemakers, and things. But I think for me, the B2B side is more interesting, and the applications right now are more valuable. The big changer is going to be the automobiles when they become self-piloting and we start to think about connecting the entire grid of automobiles for management.
Mm-hmm. Mm-hmm.
And I have another one for you. What sectors of the economy do you think will be most affected by the Internet of Things?
Mm-hmm. Wow, that's a tough one because I kind of see every sector being affected. You know, I think there are sectors you're going to see it happening earlier. I mean, one you could argue to some extent, some of the new business models, like for example, Uber, wouldn't be possible without IoT kind of capability, where you can see where drivers are, see where customers are, and you can have the intelligence built into the system to connect them. So I think in some industries, such as taxis or transportation, we're already seeing it happen and have a very disruptive effect on the business models. I think we'll see it in almost every industry at some point. I think it's just a matter of when.
Good point. I agree on transportation. Certainly in Europe, most of the trucks are being monitored by GPS. UPS here in the U.S. has about 20 diagnostics on each package car, that what they call their trucks, to determine driver safety and whether they exceed the speed limit, make left-hand turns, lock the vehicle when they go to deliver a package, and when the drivers exceed too many of those, they call them in for safety counseling. I think we'll see it in more and more in security applications as well. You know, near field communications in identification cards for employees will know where you're at and how long you've been in this room and where you went from there. And security is also going to be a problem in manufacturing too. Mm-hmm. Data security, because we'll have to have security at the machine level, and then at the plant level, and then at the divisional level. And so there'll be a layer of security issues around data as we implement it more and more in the manufacturing area.
Agreed.
Another question has just come in. Other than sensors, what other components are needed to support Internet of Things?
Well, it's interesting because, again, I kind of go back to the big data, because certainly on a lot of devices, you're having sensors built in so that's capturing the data. But still, in many cases, we're seeing unstructured data being used. Again, it could be operator logs. It could be, you know, one of the great examples is kind of interesting on the railroad application. They're actually trackside listening sensors that capture the noise. So it's not necessarily direct sensors on the device, but it may be sensors associated with the device. So I think there are going to be a lot of different types of data that come in. The key is, do you have a way to capture the data in a kind of timely manner and get it back into the analytical system? So it's really all about, you know, can you get the data? And to some extent, it really doesn't matter whether it comes from sensors or not. I think we just see sensors as an automated, low-cost, kind of seamless way to do that. Wes, your thoughts on that?
I agree. Sensors are our starting point, but not necessarily sensors. The data can be captured in other ways. But then the real question becomes, how do you store and process the data? And one system that's emerged so far is called the Hadoop distributed processing system. And what they do in that system is they have multiple servers in different locations, and the data is redundant because it's a system that's set up for real-time processing. And if a server goes down, yeah, you could bring it up if you were doing data mining, but for real-time data, you have to have the data available all the time. So this is redundant data in different locations on different servers to be able to continue streaming data and sense it. So and I know, Ed, you know other systems beyond Hadoop as well.
Right. And there are a lot of different models and kind of processes for doing that in systems, but certainly Hadoop is a significant one. I'm sorry.
And another one just came in. On the B2B side, what are the trends outside of manufacturing as far as the Internet of Things goes?
One of the things that we're finding is it's changing the nature of the buyer-seller relationship. And that is more and more, it's leading to servitization. And I know Ed's done a study in that area. Ed, why don't you discuss that?
Yeah, and actually what we're seeing is because of this availability of data, it's now leading to business models that really are focused on customer outcomes and driving customer outcomes versus selling a product transactionally or providing a product transactionally. And so because you have this data coming in, you're now able to actually build new models and again, build new services around these. So for example, I'm going to go kind of to one people don't think of much, but if you're a large corporation and you have 20 or 30,000 printer devices, which is, by the way, not uncommon, there is a massive amount of things that you can do if you know data about the users and the devices to optimize deployment of those and actually end up with a much more well-allocated set of devices. You can actually, we're seeing today something called managed print services where firms are outsourcing their entire fleets and the vendors are able to remotely monitor and manage those fleets and really optimize their operations around that. So it's kind of opening up new, as Wes said, it's really kind of changing this buyer-seller relationship and moving it from, let me sell you a product and you figure out how to get use and value out of it to, let me provide you this product and the services associated with it so that you're getting all of the value, and the value you get is actually using the product, not necessarily owning it. And that's really changing, I think, a lot of models out there.
Okay, and I have another one. You mentioned RFID as the first device that was used, and now there are near-field devices. Are there any specific devices beyond NFDs that you think are obvious candidates for the next big thing?
Well, I did some work for a company in Taiwan, and they make the embedded semiconductors and sensors that go in equipment, and so they were looking for applications and what industries would take off in the near future. I think clearly we've talked about manufacturing, we've talked about transportation, agriculture, and healthcare are going to be top application areas as well.
There's a interesting one, Wes. What I really enjoy is some of these what seem to be kind of unglamorous industries or low-tech industries that are turning very high-tech. Was recently speaking with a farmer that produces row crops, corn, soybeans, those types of things, and he has a planner that has, it's a very large planner. I think it's 25, 30 foot wide, and it can feed up to 4 different types of seeds simultaneously to different parts of the planner, so that it is optimizing the type of seed for the specific soil on a either foot by foot or yard by yard basis to optimize planting and crop production. I mean, it's pretty sophisticated stuff where you're integrating satellite data, real-time data on where the planter is at, what corn types are in the planter. I mean, it's really fascinating technology. So I think we're going to see really just some disruption in areas that you really wouldn't think about it, because it has such potential to optimize how businesses operate.
Could you elaborate a little more in regards to specific devices?
In terms of which devices?
Yes.
Well,
versus fields.
Yeah. Well, let me give you another example. And this is actually, the technology is there today. It's not been implemented fully yet. But Samsung has smart refrigerators that can weigh what is being taken out of the refrigerator, what's being put into it. It's technically able to know who is taking something out or putting it in by looking at your smartwatch or your iPhone or whatever device you're carrying with you that has near field communications and can communicate who you are. You can definitely see an application to where that data could be fed from the refrigerator into your doctor's office, possibly even into your healthcare provider, to provide kind of a closed loop system on, are your eating habits consistent with your company's insurance policy and optimal health? And are you at a high risk because you like to have that late night ice cream? So maybe you have a high cardiac risk. So there really is the potential to integrate this in almost any type of device. We're seeing it now in clothing, in shoes. We're seeing it in the business world, in everything from autos and wheels to, as Wes pointed out earlier in the presentation, bearings, to where it's literally monitoring oil viscosity and heat within the bearing. So it's pretty unlimited where these devices or sensors can sit.
The Southern Company here in Atlanta is the largest electric utility holding group in the U.S. They've been working on a smart home or smart house where the whole home will be embedded with diagnostics to control heat and light, and that smart refrigerator that Ed was talking about is part of it. For right now, I think the RFID is going to really drive a lot of these applications in ID cards and in clothing and in other kinds of machinery. Then the next level up would be some sort of embedded sensor or microprocessor that could actually, if you go back and think, there are already machines that have microprocessors embedded in that actually control at the machine level the process of the machine. So I visited Finland a number of times, and their paper machines over there are controlled for a number of different issues in the paper as it's being manufactured, the viscosity and the luminescence and the translucence and other things on the paper. And as it varies or starts to vary off of the set dimensions, the machine is controlled back into place. There's no need for an operator to try to be controlling the paper machine as it rolls. It's done automatically. Measurement, Accuray are companies that made that kind of equipment.
And I do have one more, Wes. What types of companies that enable IoT do you see benefiting from the Internet of Things growth? You mentioned servers, you mentioned data centers. Are there others that you would highlight? The
big question to me is who's going to control this data Is it going to be the company that owns the equipment with the embedded diagnostics? Are they going to have the capability to gather all that data, store it, and analyze it, and use it for predictive analytics? Or will it be the supplier of the equipment that will continue on a service basis to the customer to monitor that and then feedback solutions to the customer in a servitization kind of way? Or will a third party emerge, somebody independent, a consultant, or a service company that will collect the data from the customer, analyze it, and feed it back to both the manufacturer of the equipment and to the customer, the owner? Ed, what's your thought?
I tend to agree with you. I think really the control of the data and the if you will, the processing of the data, the decision making coming out of the data is where the real value is going to lie. And the question is going to be, who's going to own that? Where will that sit? And it'll be multiple places, I think, over time.
Okay, with that, unless there are any more questions and no others have come in at this point, I'd like to, first of all, remind everyone that following this broadcast, it is being recorded, and those of you who registered will be receiving links to the material that you can download, as well as to the broadcast. Again, it will be available on B2B Pulse for members, and for non-members, it will be available on our website for a period of 30 days.